Hey everyone, welcome back. All right, we're going to do a problem. Before we get into 3.4, we'll do a problem from 13.3. So let's take a vector field. And we're actually going to say that it is conservative. We know it is conservative. Or also known as a gradient field. Okay, so we're given the field capital F of XYZ with a little arrow on top equals. I'm going to write it down, make sure I write it down carefully because I sometimes write this one down wrong. Y squared Z plus 2x Z squared, that's the I coordinate, plus 2xyz, that's the J coordinate, plus xy squared plus 2x squared z, that's the K coordinate. Okay, now I'm going to write this as P of xyz in the I plus R of xyz in the J plus, oops, that should have been Q, plus R of xyz in the K. All right? Just easy way to remember them. P, Q, R, one after another in the alphabet. Okay? All right. So, if this is a conservative field, which we know it is, okay, that means that it's the gradient of some function, scalar function f. Okay? So, that means that P of x, y, z is the partial with respect to x of f. Okay? So, let's go ahead. I want to show you something. We're not going to take the partial with respect to z, or we're going to just take the partial with respect to y of P, which is, so the partial with respect to y here of this one is going to be 2yz. And we're going to take the partial with respect to z of P. Oops. Partial with respect to z here of this is going to be y squared plus 4xz. Okay, now I want you to think about these things as this is the partial with respect to y of the partial with respect to x of our original scalar function f. This is the partial with respect to z of the partial with respect to x of our original scalar function f. Okay, now let's take a look at the Q. Q of xyz, which let me write it down as 2xyz. That's the partial with respect to y of our scalar function f. Okay, so now let's take the derivative with respect to x of this thing. That's going to equal, so the derivative with respect to x of this thing is 2yz. Which, we think about this in terms of the original scalar function, the derivative with respect to x of the derivative with respect to y of f. And so what I want you to notice is that this and this are the same, and they match, as they should, because the mixed second partials of our original f match. So these two sort of get a match. Let's label them with a 1. Maybe a smaller 1. That's not seeable. We'll come back to that. Okay. Let's take the partial with respect to z of q. Partial with respect to z of q, that's going to be, well, the derivative of this with respect to z is 2xy. And that's the derivative with respect to z of the derivative with respect to y of f. Okay, let's take a look at the r of xyz. So r of xyz r of xyz, remember, is xy squared plus 2x squared z. And that is the partial with respect to z of our original scalar function f. Okay, let me move that a little bit out of the way. So, if we take the derivative with respect to x of f, of r, we should expect it to match with one of the previous ones, the derivative with respect to z of p. Okay, let's see if that happens. Derivative with respect to x here is going to be y squared plus 4xz. Very easy to make a mistake here. Oh, but nope, it matches. Okay, so this matches the y squared plus 4xz, matches with what we got up here. Okay, and likewise, the partial with respect to y of r equals, it should match the partial with respect to z of the q. Okay, so taking the derivative of this with respect to y, 2xy. And look at that. It matches with this perfectly.